In this video, I want to try to give you a little bit more information about the difference quotient and hopefully make a connection between something that you already know and also give you some insight into why it's important. The difference quotient is in, I believe, lesson 9, and it's really kind of like an application of the average rate of change over an interval. The formal definition of the difference quotient is it computes the slope of a secant line through 2 points on the graph of function f. Really, the difference quotient is similar to the idea of slope. When we talk about slope, we're talking about only linear functions or lines. But in reality, we also have functions that are curves, which you can see in this graph here is that red or orange looking portion of the graph that's curved. So it's not a straight line. So it's difficult because its slope or tilt changes depending upon which part of the graph you're looking at. So we tend to look at it over an interval or at two different points, and we connect. So we choose 2 points on that particular curve, and then we draw a line through those curves, through those 2 points. That line that we draw is called the secant line. And then the difference quotient is basically we're going to find the slope or ultimately the average rate of change for that red curved line. The difference quotient is so important. It's a skill you need to learn and be able to simplify the difference quotient because it is used extensively in calculus. It's actually part of the definition of the derivative in calculus. And so I want to kind of show you here. You probably already know the formula for the slope of a line. And in case you're unfamiliar with that terminology, let me see if I can sketch you a picture. So if we have a coordinate grid, and then we have a line on that coordinate plane, and we want to find its slope, we focus on 2 points. So we would have the point x1, y1, and a second point, which is x2, y2. And I hope at this point you do know that to find the slope, of course, you subtract the y's, which is your rise or the vertical change, and then you subtract the x's, which is your horizontal change or your run. Okay, so you're probably already familiar with how to do that. Well, if we look at the formula for the average rate of change for a nonlinear function, let me see if I can rough sketch you one of these here. Okay. Okay, so we would have this curve. Okay, and again, we have 2 points on that curve, which we connect by the secant line, and we refer to this. It has an x value of x, and its corresponding y value in function notation would be f of x. And then we choose a second point, and instead of calling it like x1, y1, we label this x plus h. And then it corresponds to f of x plus h. So you really end up with 2 ordered pairs. You have the ordered pair x and f of x. Well, that's like having x1, y1, and x2, y2, so that virtually this formula here, this little delta stands for change in, so it's the change in y compared to the change in x. We have subtracted the y's and we subtract the x's, which simplifies to this formula right here, which is called the difference quotient. But it really represents the average rate of change, or, quote, the slope of the nonlinear function. The formula probably looks very daunting to you. One, it looks like a fraction, which involves division, and then you've got some subtraction going on. So what I would encourage you to do is to break the formula into like 3 smaller problems. You're given f of x in the formula. Okay, so if you want to think about it, what I'm saying is that in this formula for the difference quotient, this piece, the f of x, is given in the problem. So then we need to find f of x plus h, which is basically a substitution problem. It's a good old basic algebra skill that hopefully you've already learned. So we substitute x plus h into the function that we're given, and we have to simplify. Once we've done that simplification, we have both of the pieces that we need for the numerator or the top. So we need to subtract those. We subtract those by combining or subtracting like terms. Once we get that result, we may have to do some factoring, but we ultimately need to divide it by h. And the answer that you get then is the difference quotient. So I want to look at a couple of examples, and I'm going to try to break it down using those steps that I just outlined for you. So step 1 is I'm given f of x. So f of x is 3x squared. Step 2, I want to find f of x plus h, which means I'm going to substitute x plus h into the given function wherever there is an x. So I would have 3 times x plus h squared. Now I need to simplify that, okay, but be careful. This idea of squaring, okay, remember, that literally means you need to do x plus h times x plus h, and you need to use the full method or the distributive property to do that. So I'm going to multiply together x plus h and x plus h, and I use full to do that. So I have 3 times x is x squared, x times h is plus hx, h times x is plus hx, and then h times h is h squared. Okay, so I can simplify a little bit there inside the parentheses because I have x squared, and then hopefully you notice you have 1hx plus 1hx, which would be 2hx. So I have x squared plus 2hx plus h squared. And then finally, I need to distribute the 3 so that f of x plus h is 3x squared plus 6hx plus 3h squared. Okay, so that represents f of x plus h. Okay. Step 3, then I'm going to subtract the result that I got in step 2 from, I got to do f of x plus h minus f of x. Okay, so I'm going to color code it for you. Okay, so f of x plus h is what I have written in green. So that's 3x squared plus 6hx plus 3h squared minus, okay, f of x, which is 3x squared. Now be careful, okay, and watch the signs here, okay? So if I do this subtraction, 3x squared minus 3x squared is no x squared. So that leaves me with 6hx plus 3h squared. And this represents the top. Okay, so this is the numerator of the difference quotient. Then step 4, I'm supposed to take that expression, 6xh plus 3h squared, that whole thing, and I need to divide it by h. Okay, so I notice that in this top piece, both pieces have an h in common, so I'm going to factor it out. Okay, so I have an h, so I have 6x plus 3h, all divided by h. I have an h in the numerator and one in the denominator, so it divides out. I'm left with 6x plus 3h, and this would be the difference quotient for the function f of x equals 3x squared. Now, just as a little heads up and kind of let you know what happens in calculus, we then talk about what happens as this value, as the value for h gets smaller and smaller and smaller and smaller. Okay, so as h gets closer and closer and closer to 0, I hope you realize this piece would go away so that ultimately we have a value of 6x. Okay, but that's the difference quotient, is 6x plus 3h. Okay, so I want to do one more, and it's a little bit more, initially at least, a little bit more complicated in terms of the function itself, but the process is still the same. So number 1, we're given f of x, which is 2x squared minus x plus 3. Step 2, I want to find f of x plus h, which means I'm going to substitute x plus h into the given function wherever there is an x. So I'm going to have 2 times x plus h squared minus x plus h plus 3. Now, it's important to remember that in front of this second parenthesis, remember that's an understood 1 there, so we got to make sure we distribute. So then I've got to simplify, but remember, this is really 2 times x plus h times x plus h. Okay, I'm going to go ahead and distribute the 1. Negative 1 times x is negative x. Negative 1 times h is minus h. Plus 3 tags along. Okay, so then I'm going to come back and I'm going to multiply together the x plus h and the x plus h. And again, I'm going to use full to do that. So I have 2 times x squared plus hx plus hx plus h squared minus x minus h plus 3. I can combine like terms inside the parenthesis. 1hx plus 1hx is 2hx. So I have 2 times x squared plus 2hx plus h squared minus x minus h plus 3. All right. Then I need to distribute the 2. Okay, so I'm going to distribute the 2. So I have 2x squared plus 4hx plus 2h squared minus x minus h plus 3. And if there's anything that you can combine there, you need to combine it together, but I don't believe there is anything. So this represents f of x plus h. Then step 3 is I take f of x plus h and I subtract f of x. Okay? So I'm going to have, and I'll try to color code it for you. It may be helpful if you do that for yourself. So I would have 2x squared plus 4hx plus 2h squared minus x minus h plus 3, okay, minus 2x squared minus x plus 3. Okay, again, be careful. Make sure you distribute the negative sign there. Remember, there's that understood 1. Okay. So I have 2x squared plus 4hx plus 2h squared minus x minus h plus 3 minus negative 2x plus x minus 3 when you distribute the understood 1 there. And then I'm going to come back and I'm going to combine like terms. 2x squared minus 2x squared zeroes out. Whoops. Sorry about that. Looks like I lost an x. Hold on. Plus x. Okay. So I have minus x and plus x, which zeroes out, and positive 3 minus 3, which also zeroes out. So I'm left with 4hx plus 2h squared minus h. And that gives me the numerator. That corresponds to f of x plus h minus f of x. And then I have to divide that by h. Okay, so I'm going to take that piece in step 4. I have 4hx plus 2h squared minus h all divided by h. So I'm going to do my factoring. I have an h in common all the way through, so I have 4x minus 2h minus 1 all over h. And since I have an h in the numerator and an h in the denominator, they will divide out, and my difference quotient is 4x minus 2h minus 1. Guys, it's really all algebra manipulation. Take your time, keep yourself organized, and it may help you to use colors like I did.